Hello everyone, this is Jahangir, your maths teacher. As I got so much request from the students, they could not understand 3.5 exercise related to intersection of a line and the circle. And we don't have time, so I thought I should make a video on this. I'll share to you, you can understand better. And when we will have class, over there also we can have discussion on this. So let's get started. The topic is intersection of a line and a circle. We will have one line and we will have one circle. And now we are going to analyze when one line is going to touch the circle or intersect the circle, or it won't touch and won't intersect. So let us see. So this is one line, I can say, and this is one circle, I can say, right? But in this case, you can understand this line is neither touching the circle nor intersecting. So this is one of the possibilities. The second case can be this one. We have a circle, right? And at one point, this line will touch like this. So this is our second possibility, right? And the third one can be like this. There is a circle and that line can pass the circle and intersect the circle at two distinct points, right? So we have to discuss all these three cases in terms of maths, in terms of conditions. So how can we learn all these? Let us understand here. I am going to consider equation of the circle and equation of the straight line. Okay? And I am telling you beforehand, I will try to solve those two equations. If I will get some values of x, it means my line will be intersecting the circle or touching the circle. If I am not getting any value of x, real values of x, it means this line and this circle is not touching or intersecting. What is the meaning? I will explain in detail. Okay guys, so let equation of this circle, let equation of this circle x square plus y square plus 2gx plus 2fy plus c equals 0. Okay, this is the equation of circle. And let equation of this line as y is equal to mx plus c. This c and this c, these two be constant and these two may be same, may be different. So I can say I can present this by c dash, right? Just to make difference between these two. Okay, so we have two equations, equation of line as well as equation of circle. Now, if we have graphical picture, then from here we can say, yeah, this is not intersecting, touching, intersecting at two distinct points. But what about the equations? When we have only equations, this and this, we don't have graphical analysis, then how can we solve? How can we understand? This would be the question. Let us solve these two equations. Solve two given equations, right? What are those two given equations? Y is equal to mx plus c and this one, x square plus y square plus 2gx plus 2fy plus c dash equal to 0. Now we are going to solve these two equations. Now try to understand. After solving, if you are getting some real values, it means this possibility can be there or this possibility can be there. But after solving, if you are not getting real values, it means this possibility you will get. Why? Again, we will understand. But before that, let us understand how you will solve. So this is simultaneous quadratic equation related to chapter 1, quadratics. So either we can substitute x from here to here or we can substitute y from here to here. It is depending on the question which one is easy to substitute. So according to the equation which I have provided, this is y equals mx plus c, right? So I should replace y. So I will put y over here as well as y over here. Okay? So check x square. So it would be x square plus y square. Instead of y, I will write mx plus c. So mx plus c whole square. Then plus 2gx. This one 2gx plus 2fy. And what is y? Y is this mx plus c. Mx plus c and plus this c dash. C dash equal to 0. Now guys, what happened over here? I have replaced y variable with x. Now I got quadratic equation in terms of x, right? And in quadratic equation, you are having three possibilities. Whether your quadratic equation will give you repeated roots, whether your quadratic equation will give you two distinct real roots, and there is also one possibility, your quadratic equation won't give you any real roots. That would be imaginary roots, right? So, and you have already learned what are the conditions. Okay, so first one, if quadratic gives two distinct real roots. What was the condition? Condition was b square minus 4ac greater than 0, right? When two distinct real roots you will get. And two distinct real roots means you got two values of x. When you got two values of x, you will put one value of x over here, you will get according y value. You will put another value of x, you can get another y value. So, when you will have two values of x, then you can have two coordinates. And when two coordinates, you can plot over here. For this condition, for this condition, or for this condition. Of course, for this condition. So guys, when you will substitute linear, a straight line to the circle, and if b square minus 4ac is greater than 0, it means this possibility will be there. And so we can write condition here, b square minus 4ac greater than 0 and two distinct real roots we got. Okay, now second case. If quadratic gives two repeated roots, two repeated, or we can say equal roots. At that time, we are giving condition b square minus 4ac equal to 0. So if this quadratic will give us b square minus 4ac equal to 0, it means it will give you two repeated roots. I mean equal roots, not two distinct, equal roots. It means ultimately we got one root. It means this line will touch the circle because you have only one root. So it will touch the circle. So at this time, condition would be b square minus 4ac equal to 0. And at this time, this line will be called tangent. Okay, this is not a tangent. This would be a tangent. A line which touches the curve at only one point, that's called the tangent. So at this time, when b square minus 4ac equals 0, then you will have tangent. Now third case. Yeah, this quadratic maybe won't give you any real roots. So no real roots, or we are calling it imaginary roots. Okay, imaginary roots. For that, our condition was b square minus 4ac less than 0, right? When we have solved it and we got b square minus 4ac less than 0, it means we will say, yeah, there is no any real roots. It means these two lines, these one line and the circle won't intersect. So guys, no real roots means neither touching nor intersecting. It means b square minus 4ac less than 0. Okay. So here I will write neither touch nor intersect. Okay. Tangent means touch at one point. Touching at one point, I can say. Touching at one point. Okay. And here intersecting at two distinct points. Two distinct real roots means intersecting at two distinct points. Okay. So right now just I have explained theory. Now I am going to explain everything with the help of one example. Randomly I will take one circle and one line, and then I will tell you how to solve. First of all, how will you get this kind of quadratic, and then how can you give a result whether the line and the circle are intersecting, is tangent or not intersecting. Okay, so let's understand whatever I have explained with the help of one example. So question. Check whether the line y minus 2x plus 1 equals 0 and the circle x square plus y square minus 2x plus 3y plus 1 equals 0 are intersecting at two distinct points, or tangent, or neither intersecting nor tangent. Okay, so we are going to discuss this question. Okay, so first one is y minus 2x plus 1 equal to 0. So first of all, I will write y equal to 2x minus 1. Okay, 2x I will shift to right side plus 2x, 1 I will shift to right side minus 1. So y equals 2x minus 1 I will get. And another we have circle, which is x square plus y square minus 2x plus 3y plus 1 equal to 0. Okay, now I am going to solve this and this. So I will use y here and y here. That is called substitution. Substitution. So that is x square plus y. Y I will write from here. That is 2x minus 1. X square plus y square. Y is 2x minus 1 whole square. Then that's minus 2x as it is. Now plus 3 times y, right? And what is y? Y is 2x minus 1 and then plus 1 equal to 0. Okay? So we got quadratic equation here, but in the previous concept, I just left my equation till this step and then I explained. But here we can't. We have to solve further. So let's solve it. So this is x square plus 2x minus 1 whole square. That would be 4x square minus 4x plus 1. This is minus 2x. And 3 times 2, that is 6x. 3 times minus 1, which is minus 3, and then plus 1 equal to 0. Right? Now x square plus 4x square. What we have? We have 5x square. Now this is minus 4x and minus 2x, minus 6x and plus 6x. This will cancel. Then we will have 1 and plus 1, 2. 2 minus 3, we will have minus 1 equal to 0. So guys, we got 5x square equal to 1 and we got x square equals 1 over 5, right? X square equals, we got 1 over 5, and then we can write, if x square is 1 over 5, we can write x is plus minus 1 over root 5. Okay, so directly we got x value. Did you understand? We have solved, we got x value. We got x value, it means, and even 2x we got, it means this line and this circle will intersect at two distinct points. right? So right now we have already shown this. But you guys are thinking, sir, this is a very simple quadratic you got. And x and x got cancelled, that's why. But you have explained us in terms of b square minus 4ac. But here you got very simple equation. So can you relate this equation with b square minus 4ac concept so that it will be easy because you have taught like that? Yeah, sure, no problem. Okay, that's 5x square minus 1 equal to 0. This is my quadratic, right? Okay, so this is 5x square. There is no x. I can write 0 times x and then minus 1 equal to 0. Why? Because I am going to convert my quadratic in terms of ax square plus bx plus c. Okay, the standard form of quadratic equation. That's why. So 5x square minus 1 equals 0. This is same, 5x square minus 1 equal to 0. There is no x. I have written 0 times x. This is 0 times x. Okay. Now relate this with ax square plus bx plus c. So what is a? A is 5. What is b? B is 0. What is c? C is minus 1. Right? Now you can find b square minus 4ac. B is 0. Okay, so this is 0 square minus 4 and a is 5 and c is minus 1. So guys, I got b square minus 4ac is 0 square is 0 and minus times minus is plus 20 I got. So what I have proved? I have proved b square minus 4ac is greater than 0. And when b square minus 4ac is greater than 0, then you will have two distinct roots, which we already found here. Okay, it means the the line and the circle will intersect at two distinct points. So this is a circle and this is a line. So this kind of graph you will have. Another question is, if it will intersect at two distinct points, then find those two distinct points as well. We have to find the points right now. We can find, there is no issue. Already we found x value, right? So for example, this coordinate x is 1 over root 5. Then this coordinate will have x coordinate minus 1 over root 5. Okay? Now we have to find y. Y for this as well as y for this. How can we find y coordinate? Please try to understand. We can use either this equation or this equation. Right? This equation. But we are smart. We are not going to use this one because it's a very lengthy calculation. We will use this one. Y equals 2x minus 1. Okay? So y equals 2x minus 1. This is the equation. We can put x equals 1 over root 5 in this or in this. So this is a simple one. So I should use this. So y equals 2x minus 1. We need to find y at x equals 1 over root 5. Okay. So put y here, x here. Then 2 times 1 over root 5 minus 1, which is 2 over root 5 minus 1. Okay, this is my y. Okay, next one. Y is 2x minus 1 at x equals minus 1 over root 5. Okay, so put x is minus 1 over root 5. So 2 times minus 1 over root 5 minus 1. So this is minus 2 over root 5 and minus 1. So since I have taken this question on my own, that's why we did not get nice coordinate like 1, 2 or 3, 4. But it's fine. I was intended to explain the concept. So I have explained when x is 1 over root 5, y is 2 over root 5, 2 over root 5 minus 1. Okay, and when x is minus 1 over root 5, y is minus 2 over root 5 minus 1. Okay, so we got two coordinates. But when you do question from your textbook, then you will have some standard coordinates like 1, 2, minus 5, 4, maybe some integral values you will have. So, till now I have explained the concept. Now I am going to solve some questions from your textbook so that you will have enough confidence. Yeah, now you can solve the question. Find the value of k if x equals y plus 2 and y equals x square plus 3x plus k neither intersect nor touch, right? So this is a line and this is of course not a circle. This is not a circle, but this can be any polynomial. This can be any curve, okay, right now. Anyways, there is no problem. What's the question? This line and this curve neither intersect nor touch. Then we have to find the value of k. Okay, so first of all, let's break the question. This would be any curve. Okay, I don't know which curve is this. This would be any curve. For example, this is any curve. And this would be a line, this line. So this kind of figure you can imagine. Because line and the curve won't intersect, won't touch. Okay, and for this, you know what should be the case. B square minus 4AC. Any idea? Less than 0. B square minus 4AC is less than 0. Then only you will have this kind of condition. Okay, so y equals, I have x square plus 3x plus k. So I can write y equals x. Instead of x, I will write y plus 2. So y plus 2 whole square plus 3 times x. X is again y plus 2. So y plus 2 and plus k, right? I got y equals x square. X is y plus 2 whole square plus 3 y plus 2 plus k. Okay. So y equals, I got y square plus 4y plus 4 plus 3y plus 6 plus k, right? When you expand it, then you will have y square 4y plus 4, 3 times y is 3y, 3 times 2 6 plus k. And now take this y to left to right side. Then you will have y square. This is 4y plus 3y, 7y. And when you will take this y to right side, it will be minus y. So 4y plus 3y, 7y and minus y. You will have 6y. So y square plus 6y we got, right? And 6 plus 4 is 10. So it would be 10 and plus k. So it would be k. And this side is nothing. That's 0. So 0 I can write here, right? Again, y square, 4y plus 3y, 7y, subtract 1y. So 6y, 6 plus 4, 10 plus k. So y square plus 6y plus 10 plus k I got. Guys, 10 plus k is constant. Here if I ask you to find or to convert or to relate this quadratic with the standard quadratic equation like ax square plus bx plus c, then you will say value of a is 1, value of b is 6, and guys, value of c is 10 plus k. Okay, here is a problem. Students are thinking 10 is the c, but not k. K is also a constant. So 10 plus k would be a combined constant. So a is 1, b is c, and b is 6, and c is 10 plus k. Okay, now it is already mentioned in the question, neither intersect nor touch. It means we have to apply this condition according to the question. So b square minus 4ac less than 0 concept we have to apply. B square minus 4ac less than 0. Now, what is b? B we have 6. So 6 square minus 4, a is 1 and c is 10 plus k. Less than 0. Then we got, this is 36, 4 times 10 that is minus 40. Minus 4 times this is minus 4k, less than 0, right? So 36 minus 40, minus 4, minus 4k, less than 0. Take 4k this side, minus 4, less than 4k, right? And this it means 4k is greater than minus 4. So I can write like this also, 4k greater than minus 4. Now I will divide both sides by 4 here as well as here. I got k greater than minus 1. So guys, what was the question? Question was, find the value of k if this and this neither intersect nor touch. For that, k must be greater than 1. Okay. Now, if I ask or if I convert this question in 3 parts. First part is neither intersect nor touch. K greater than -1. This is my from here. K greater than -1 for neither touch nor intersect. Okay. Second question. For tangent. Okay. For tangent, we have b square minus 4ac equal to 0. Yes or no? For tangent, b square minus 4ac equal to 0. So already we found here. This is a calculation of b square minus 4ac. This one. B square minus 4ac we have done. We got this. B minus 4 minus 4k. So b square minus 4ac we have already calculated here. Minus 4 minus 4k equal to 0. And take 4k this side. So minus 4k equal to plus 4. And divide by minus 4. So 4 over minus 4, that's minus 1. So k equal to minus 1. When k is exactly equal to minus 1, then this line will be a tangent to this curve. And third question is, intersect at two distinct points. Intersect at two distinct points means b square minus 4ac greater than 0. Yes or no? And already we found b square minus 4ac. That's minus 4 minus 4k greater than 0. You can solve here. You will get k less than minus 1. You can solve it. So when b square minus 4ac less than 0, this is a curve and this is a line. Neither touch nor intersect. For the tangent, this is a curve and this is a line but touching at one point. Intersecting at two distinct points means this is a curve and intersecting at two distinct points, like two distinct points you will have. Okay? So I hope you understood this question again. This is another example. Find the value of k if y equals 4k minus x and y equals 3x minus kx square will touch at one point. It means tangent. And also find the point when the line and the curve touches. I mean, what's the question? The line and the curve will touch at one point. Okay, so this would be a curve and this would be a line, but this line touching at this point. So we have to find this point also. And this is already given in the question. Line and the curve is touching at one point. Okay, so it means tangent, and tangent, this is a tangent, and we know the condition b square minus 4ac equal to 0. Okay, so let's solve. We have y equals 4k minus x and y equals 3x minus kx square, right? So this y we can replace by this. So guys, okay, I will write y equals, we have 3x minus kx square, right? And another, we have y equals 4k minus x. So this y I can put here, and instead of this y I can write 4k minus x. So y equal to 4k minus x I have written, and this is 3x minus kx square. Understood? This y I have replaced by this expression. This is also y. So 4k minus x I have written, then 3x minus kx square I have written. Now take everything to left side. Minus kx square you can take to left side. That would be kx square. Okay. This is 3x. You can take this side. Minus x minus 3x. Minus 4x you will have. And this is plus 4k, which you have to write as it is over here. Okay? Once more. Minus kx square, take left side, plus kx square, 3x, left side, minus 3x, minus x, minus 4x, and plus 4k. This is your quadratic. Okay, if you compare this with the standard quadratic equation ax square bx plus c, then you will get a equals k, b equals minus 4, and c equals 4k, right? So we got a, b, and c. Since line and the curve are touching at one point, so tangent case, at that point we know the concept is b square minus 4ac. So I will apply b square minus 4ac equal to 0. Now b is minus 4, so minus 4 whole square minus 4 times a is k and c is 4k, okay, equal to 0. So here I got 16 minus 4 square, and 4 times 4 is 16, and minus k times k, that's k square. Okay, then take 16 right side, so minus 16k square equals minus 16. Divide by minus 16 here and minus 16 here. Got cancelled, you get 1. So k square equal to 1 we got. Okay, so when k square equal to 1 we got, then here we got k equals plus minus 1. K square is 1, then k equals plus minus 1. Actually, we had two questions. Find the value of k. K is plus minus 1. Second is also find the point when the line, the curve touches. No problem. We got value of k. Okay, put value of k to this quadratic equation. Put value of k to this quadratic equation. So if k equal to plus 1, then our quadratic equation would be 1 times x square, k is 1, so 1 times x square minus 4x, and 4 times 1 equal to 0. So I got x square minus 4x plus 4 equal to 0. Guys, this is x minus 2 whole square equal to 0. From here you will get x equal to 2. Okay? And when you got x equals 2, you can find y. So you can find y from here. Y is 4k minus x. So 4 times k already we have plus 1, and minus x we already found 2. So 4 minus 2, that is 2. So one possibility, because we have two values of k. So when k is plus 1, so we got 1 point, x and y. So one possible coordinate is 2, 2. Okay, x is 2, y is 2. 2, 2. But if k equals plus 1 already considered, if k equals minus 1, then okay, so then this y would be 4 times minus 1 and then minus x. So y equals minus 4 minus x, right? This is y equals minus 4 minus x we got, and another equation is this, y equals 3x minus kx square. Y equals 3x minus k is minus 1 x square. So y equals, I got 3x plus x square. Okay, see, these two equations we got. Now if we solve these two equations, then also we can get the answer. So what was the solution of these two? I had written over here. It was, I think, kx square minus 4x plus 4k, right? This was the solution of these two. By the way, k is minus 1, so write minus 1. So minus 1x square minus 4x plus 4 times minus 1 equal to 0. What I got? I got minus x square minus 4x and minus 4 equal to 0. Now multiply by minus 1 both sides, you will have x square plus 4x plus 4 equal to 0. And this is x plus 2 whole square equal to 0. So x equal to minus 2 you will get. Okay, x we got minus 2. You can put x equal to minus 2 here or minus 2 here, doesn't matter. So this is a simple one. So y equal to, I will get minus 4 minus, and x I will put minus 2. So y equals minus 4 plus 2, which is minus 2. So another possibility, another possible coordinate is x is minus 2 and y is also minus 2. Okay, now I am telling you, don't confuse, because you got 2 points. My dear, you got 2 points because of two different values of k. If you put k is equal to 1, it would be, these two will be a different equations. When you put k equal to -1, these two will be a different equations. So you are getting two different equations, that's why you got two different answers, right? Okay guys, thank you very much. See you in the next class, and I hope you can understand